So today we will start with a topic called as error analysis using differentiation. Okay, error analysis using differentiation method. I'm going to teach you some very simple ones to very complex ones using, and we'll do few problems also on this. So error analysis using differentiation. Okay, many students face difficulty in this topic. So I thought of making video on this. So let us take, there is some equation like P is equals to A plus B. Let us take some equation P is equals to A plus B. So there is some error in measuring A and there is some error in measuring B. So how this error propagates in P, okay? So let us differentiate the equation dP upon, you can differentiate with anything like dt, anyhow it is going to get cancelled. So that would be d of A plus B upon dt. This can be written as dP by dt is equals to dA by dt plus dB by dt. So all these denominators are same, they will be getting cancelled. So dP is equals to dA plus d. This is whenever there is an equation where two terms are added, the error in P will also be getting added up. So this is what we can say whenever there is an equation given with addition sign. Next, let us go to the equation. If at all the equation is given as P is equals to A minus B, you have to keep in mind that errors are always added. Okay, errors are always added. Errors can't be subtracted because one error, another error will be increasing the error only. You cannot decrease the errors. So errors will be always added. Let us differentiate this equation. So dP by dt is equals to differentiation of A minus B with respect to dt. So dP by dt is equals to dA by dt minus dB by dt. But as we know, the errors must be always added. So we will put plus symbol here. Okay. So dP by dt is equals to, that dt's will be getting cancelled. So dP is equals to dA plus dB again. Okay. So we will do a question on this so that we will understand it better. Okay. Let us do this question. There is two temperatures of a body. Temperatures of two bodies is measured by a thermometer. T1 is equals to 20 degrees centigrade plus or minus 0.5. This is your error. Plus or minus 0.5 is your error in T1. And this 0.5 is an error in T2. Now what's he asking? He's asking temperature difference. That is T2 minus T1. Okay. In this, how much is the temperature difference? What is the error that is propagating in this? So let us take P is equals to T2 minus T1. So I can write the error in P. Okay. So dP is equals to d T1 plus d T2. So dP is equals to how much? dP is equals to error in T1 is 0.5, error in T2 is 0.5. So error in change in temperature would be 1. So P is equals to T2 minus T1. So the temperature would be 50 minus 30, which is equals to 20. And error is 1. So I can say the temperature difference permissible error will be, 50 minus 20. I'm sorry, here. 50 minus 20. Here it is 20. 50 minus 20 is 30. Okay. So 30 plus or minus 1 degree centigrade will be your answer. So the answer will be 30 degrees centigrade plus or minus 1 degree centigrade will be your answer. Okay. We'll move to next. Next, let us see how error will propagate if at all there is a multiplication symbol. Okay. So let us take an equation like P is equals to A into B. Okay. So if P is equals to A into B, if I differentiate the equation dP by dt is equals to differentiation of A into B upon P. We know that differentiation in multiplication, which is called as UV method, there I have to keep B as it is and I have to differentiate A, plus I have to keep A as it is and I have to differentiate D. Okay, dB by, yes. So what happens here? So this is dP by dt. So this becomes dt gets cancelled. So dP is equals to B into dA plus A into dB. Yes. this is what we are going to get. But I want to write it like a symmetrical equation. So what we will do is we will divide this entire equation with P. Okay. We will divide this entire equation with P. So what I'm going to get? I'm going to get dP by P divided by P divided. I can divide like this because all these are going to anyhow get cancelled and become 1. So I can divide it like this. This will become dP by P is equals to B into dA by P can be written as A into B plus A into dB. P can be written as A into B. So this B and B gets cancelled, A and A gets cancelled. So dP by P is equals to dA by A plus dB by P. This is how error will propagate in case of multiplication. Next, we will see how error will propagate in case of division, like P is equals to A by B. So in this, what happens? So dP by dt is equals to differentiation of A by B divided by dt. Okay. So we can write dP by dt is equals to, this is division method. So keep B as it is and differentiate A minus keep A as it is and differentiate B upon B square. But as we know, errors can't be subtracted. Errors are always it should be added. So it will be plus here. So dP by dt is equals to B into dA by dt. This B square, I will be distributing it to both. So this would become divided by B square into dt plus A into A by B square into dB by dt. So dt gets cancelled. You are going to get dP is equals to B dA by B square. One D also get cancelled. So dP is equals to dA by B plus A by B square into B. Okay. This equation is not looking nice, symmetrical. It's not symmetrical. So what I'll do, I will divide this entire equation with P. Okay. I'll divide this entire equation with P. So just to make it symmetrical, I am dividing this entire equation with P. So what will happen? dP by P is equals to dA by P can be written as A by B. This B and this B gets cancelled. Plus A by B square into dB by A upon B. A and A gets cancelled, B and one B gets cancelled. So you are left out with dP by P is equals to dA by A plus dB by B. Yes, this is the same thing that we have got for multiplication. The same thing we have got here for division also. We will do a question on this so that you will understand. Okay. Let's do this question where radius of sphere has been given. So radius, we know the formula. Volume is equals to 4 by 3 pi r cube. Okay. 4 by 3 pi r cube. We will do this after I'll teach you how powers also changes, so that then you'll understand it better. So let us see what can we do if there is power. Okay. So let us take the equation like some P is equals to A cube. Okay. So P is equals to A cube. So dP by dt will be equal to D into A cube by dt. Okay, fine. Now we cannot differentiate this A as the denominator is D. So what can I do? I'll be writing it as dA cube upon dt into dA by dt. So dA by dA. Yes. If I write like this, then I can differentiate the equation. So this is called as implicit method, which you have to learn in differentiation. So dP by dt is equals to dA cube by dA into this A I have sent here, this dt I will be sending here, dA by dt. Okay, this dt will be coming here, this dA will be coming here. Okay, that's all I have done. So now dP by dt is equals to, this can be written as 3 into A square. Okay, dA cube by dA is nothing but 3A square into dA by dt. This and this gets cancelled. So this is your dP is equals to 3A square into d. Now, I am not liking this equation. This is not symmetrical. Let us divide this entire equation with P. Okay. So when I divide this entire equation with P, I am going to get something like this. So dP by P is equals to 3 into a square into dA by P can be written as a cube. So a square and a cube, 1a will be remaining. Okay. So dP by P is equals to 3 into dA by. Okay. So this is how error will propagate when there is power. Now let us come to our question. Yes, we'll see our question. Our question is the radius, if the radius of the sphere is 5.3 plus 0.1, what then the percentage error we are asked, he's asking. So can I write dV by V is equals to 4 by 3 pi. This is constant value. We are not bothered about that. So 3 into dr by r. That's all. Okay. So he's asking percentage error. That means dV by V into 100 is asking. Okay. dV by V into 100 is asking. That would be 3 into what is the error in radius? 0.1. What is the radius? 5.3 into 100. This is your answer. So 3 into 0.1 upon 5.3 into 100. The answer is third option. Okay. I hope you understood this. Now let us move to a little bit complex things. Okay. So what if there is an equation that is given something like this? Okay. 1 by P is equals to 1 by A plus 1 by P. There is an equation that is given like this. 1 by P is equals to 1 by A plus 1 by B. Now how to do this equation? Okay. So I will be writing it as P to the power of minus 1 is equals to A to the power of minus 1 plus B to the power of minus 1. I can write it, yes. Now I'll differentiate it. dP by dt by dA dt and d by dt. Okay. Now I cannot differentiate like this. Okay. So what we will do? dP divided by dt into dP by dP I will do. Okay, is equals to. I can even not differentiate here. So a minus 1 by dt into dA by dA I will do. Okay. Plus d into b to the power of minus 1. I also cannot differentiate because there is no t term in a. I can write as dB by dt. Okay. Then what I will do? I will put this here, similarly with all the other terms. So dP to the power of minus 1 by dP is equals to into dP by dt. Okay. Is equals to dA power minus 1 divided by dA is equals to into dA by dt. Okay. Then plus dV to the power of minus 1 upon dV into dB by dt. This is what I am going to do. Okay. Now, what we will do is we are going to write the equation. So, differentiation of t to the power of minus 1 will be the minus 1 will go in front. T to the power of minus 2 will become into dt by dt. Okay. Is equals to, again, same thing, minus 1 will go in front. A to the power of minus 2 into dA by dt. Okay. Plus this minus 1 will come in front and this will become minus. So minus 1 into d to the power of minus 2 into dB by dt. Okay. All the dt's will get cancelled. Now what is remaining? So minus p square into dp is equals to minus a to the, p to the power of minus 2 here, minus a to the power of minus 2 into dA minus b to the power of minus 2 into dB. This is what we are left out with. Now I can cancel out all the minus symbols. So I can write dP by P square is equals to dA by A square plus dB by B square. This is our equation. Okay. Whenever this kind of things are coming, you can use this equation. dP by P square is equals to dA by A square plus dB by B square. I hope you understood this. Let us do a question on this. Okay. Let us do this question. Two resistors R1. As we know that whenever resistors are connected in parallel, 1 by R equivalent is equals to 1 by R1 plus 1 by R2. As I have just now taught you, just now we have seen dP, whenever such things come. So dP by P square is equals to dA by A square plus dV by B square. Use the same thing. So dR equivalent by R equivalent square. Okay. Same thing divided by is equals to dr1 upon r1 square plus dr2 upon r2 square. So d error in equivalent, that is how much we are going to find now. So dr equivalent by r equivalent ka square. So r equivalent square would be how much? R equivalent square would be 1 by r is equals to 1 by r1 plus 1 by r2. I can take it as 1 by 3 plus 1 by 5, which is nothing but. So 5, the LCM would be 15 and 5 plus 3, that would be 8. 1 by r equivalent is equals to 8 by 15. R equivalent is equals to 15 by 8. Okay. So R equivalent is equals to how much? 15 by 8. Okay. Now what we will do is, let us substitute this in this equation. Okay. So R equivalent square, which is, I can take it as 225 upon 64. So R equivalent square 15 by 8 whole square, it is 225 by 64. So dr1 is how much? That would be error in r1 is 0.3 upon r1 square, that is 9 plus dr2. So dr2 would be 0.1 upon 5 square, which is 25. 64 will go up. 64 into dr equivalent upon 225 is equals to, the LCM would be 225 again. So 25 into 3 would be, this will be 7.5 plus 0.9. 225, 225 gets cancelled. So dr equivalent is equals to 7.5 plus 0.9 would give me, I think 8.7. 7.5 plus 0.9, 9 plus 5 is 14. 8.4. 8.4 upon 64. This is our, what do you call it? We are going to get, which is equals to roughly how much it is. 464 means 4 ones, 4 2s are 8, 4 1 the 4, 4 1 the 4, 4 16s are. So 3 sevens, 3 5s, 5 ones, 1.3 something. Yes, we are going to get 0.13 something. We are going to, okay, we are going to get 0.13 something. We are going to get the R equivalent. Okay, so the R equivalent is how much? R equivalent is equals to 15 by 8. 15 by 8, which is 8 1.9 nearly. So the answer would be R plus or minus dr equivalent. We have found out R equivalent. We have found out dr equivalent. R equivalent is equals to 1.9. Dr equivalent is equals to 0.13. So that will be 1.9 plus 0. Plus or minus 0.13. The answer would be second option. Second option is the answer for this question. Okay, I hope you understood. Let us move to next one, that is some complex functions like tan theta or anything has come. Okay, let us take slope. Okay, slope is equals to tan theta. Okay, he will give you error in theta and he'll ask you what would be the error that is generated in slope. Okay, so I have not seen a question in this. If at all it comes, we'll see, but this I will teach you. So m is equals to tan theta is the equation for slope. Now let us differentiate it. dm by dt is equals to differentiation of tan theta by dt. I cannot differentiate tan theta with dt because I require theta term in the denominator. So what I will do, I will multiply and divide with d theta. Okay, so dm by dt into, I cannot even differentiate this m value. Okay, because I need differentiation. I need this the equation, so I can write it as d of m by dm into dm by dt is equals to d by d theta of tan theta into d theta by dt. Okay, so what will happen? D theta dt gets cancelled. dm by m is nothing but how much it will be? 1. Okay, differentiation of m with respect to dm is 1. So 1 into dm is equals to differentiation of tan theta is secant square theta into d theta. Okay, so dm by d theta is equals to secant square theta. So the error in slope is dm. dm is error in slope and d theta is error in angle. Okay. When you find out this, we can directly substitute and we can get the answer. Okay. I hope you understood this. Next, we'll do one more thing. We'll see a question that was asked, and I'll teach you how to do when this kind of questions have come. Okay. So there is an equation in modern physics where n is equals to n naught into e to the power of minus lambda into 2. Okay. So whenever this Euler's number come, okay, and they ask errors in this, first I'll suggest you do the logarithms. Okay. So put logarithm instead of doing differentiation of exponents and all, use logarithms. It will be easy. Okay. So now let us do this. I'll put logs on both sides. Natural log of n is equals to natural log of n naught into e to the power of minus lambda t. Okay. This can be written as natural log of n naught plus natural log of e to the power of lambda t. Okay. So natural log is base e. So this lambda t will come in front. This will become natural log of n naught minus lambda t. Okay. Yes. I hope you understood. This ln base e will become 1. Fine. Let us leave it. Natural log of. Yes. This is my equation. Now when I differentiate it, d of natural log n upon dt is equals to d of. So we'll do it with lambda. Okay, we'll do it with lambda. D of natural log n by lambda. So d ln n naught by lambda minus lambda t, d of lambda t upon d. Okay, I have differentiated with respect to lambda. I cannot differentiate this part. Yes, why? Because there is no lambda in this equation. So what I can do, I can write it as d ln natural log n divided by d lambda into dn by dn. This is what I can do. Okay, is equals to, this is a constant term. N naught is nothing but constant term, which is an initial nuclei that are present. So this would be 0 minus d lambda into t by d lambda will be equal to t. Okay, I hope you understood this. Next, now let us see how to do this equation. So we will write it as, so d ln n by dn into dn by d lambda is equals to minus t. As it's error, I'll put plus t. Okay. Now this ln log n with respect to dn would be 1 by n. Okay. 1 by n into dn by d lambda is equals to t. So dn into 1 by n is equals to t into d lambda. This is our error analysis equation. We will do a question on this, which was asked in JEE Advanced 2018 question. So we will see the question on that. So this question was asked in JEE 2018, I think. So let us, as we have derived just now, so n, which is nothing but dn by 1 by n into dn, 1 by n into dn is equals to t into d lambda. Okay. So where n are nuclei that are remaining. Okay. Nuclei that are remaining after decay. Okay. So let us see this. Initially, the nuclei were 3000. It is found that 1000 nuclei have decayed. How many are remaining? 2000 are remaining. So 1 by 2000 into dn value, the error in this, which is 40. Okay. The error in calculating is 40 is equals to t is 1 second into d lambda. He's asking what is the error in d lambda. So this and this goes. So d lambda would be how much? 4 ones of 50s. That is 0.02. So d lambda would be equal to 0.02. I hope I answered your question. So this is how all the complex terms or complex error analysis we can do. Okay. So if you have any doubt, you can comment below. Okay. Thank you.